don't know about you, but I have a pretty low tolerance of things that claim to be AI compositions. One of the top results on YouTube for AI music is Twoset Violin's video, "Artificial Intelligence Composed This Symphony?", where it's claimed that an AI had written the third and fourth movements of Schubert's unfinished symphony.
There's actually an AI that finished Schubert's unfinished symphony. Now, apparently Lucas Cantor, a Los Angeles-based composer for film and television, finished the work with the help of artificial intelligence that runs on a smartphone.
Wow.
Dude, what? No. Oh. Is this composed by a smartphone? Really? Is this composed by a smartphone? Really? Really?
Now, digging into this a little bit, Two-Step seems to have unwittingly given a nice publicity boost to a gimmick that was little more than an intricate advert for Huawei's new smartphone. The technical details on how all this worked are very thin on the ground. The Mate 20 Pro smartphone listened to the first two movements of Schubert's Symphony No. 8, analysed the key musical elements that make it so incredible, then generated the melody for the missing third and fourth movements from its analysis. This wouldn't have been possible without pairing the technological innovation of Huawei's AI with human expertise. So composer Lucas Cantor was brought on board to arrange an orchestral score based on the melody the smartphone composed. Okay, so basically you used a gimmick on your phone and then brought in a composer to make it seem like real music. Very impressive. I mean, fair play to Huawei. They had an idea and they went all the way with it, going as far as putting on a concert with a live orchestra. But yeah, at the end of the day, a big advertising stunt.
Is this composed by a smartphone? Really? 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 Really?
And time and again, the exciting news headline ends up the same. How AI software wrote a new Nirvana song. Well, did it really? Or did you get humans involved again? Magenta analysed the artist's songs as MIDI files. The computer creates new music that the staff could pore over to pick the best moments. If you put whole songs through, the program starts to get really confused on what it's supposed to sound like. But if you just have a bunch of riffs, it'll put out about 5 minutes of new AI riffs, 90% of which are really bad and unlistenable. So you start listening through and just finding little moments that are interesting. So most of these projects are kind of a confirmation that composers like me can still feel reasonably safe, that it's still a long time before creative musicians will need to worry about losing their jobs. Now, I don't follow every single development in AI, but I have noticed, as I'm sure many of you have, over the past few months, that its use in text-to-image generation has made just a massive leap. There are 4 big players at the moment: DALL 2 run by OpenAI, Imagen run by Google, as well as Midjourney and Stable Diffusion, both of which are independent companies and are the 2 that are currently available to test out free of charge. All of them work by taking text prompts and turning them into unique and original works of art, and the results have a tendency to leave people speechless. It works really well for surrealist prompts like teddy bears working on new AI research on the moon in the 1980s, or a bowl of soup that looks like a monster knitted out of wool, but it's also extremely effective if you give it a texture or an artist's style as a starting point. So here on the Dreamstudio website, which runs on Stable Diffusion, I simply typed in a piano underwater in the style of Salvador Dalle, and the results speak for themselves. You can click the same prompt again and get a totally different, totally original Dalle-esque work of art. The real-world uses of this technology are pretty limitless. I tried using the Midjourney bot to get potential album covers, and using just the title of my piece, The Consolation of Rain, Midjourney produced this endless series of atmospheric images, almost all of which would be great covers, all somehow capturing the melancholy, rainy atmosphere perfectly, and all free of copyright and free to use. And nothing could better sum up the 2 sides of how this technology will affect us all. It's great if you're a poor musician looking for some low-cost art for your project. Not quite so good if you're an album cover artist yourself.
You can't drop by, not in person anyway. For the customer, Amazon only exists on the computer screen.
Now, in my life, I've lived through two technological revolutions. There was the internet itself, and then the rise of the mobile internet. And in both cases, I was aware that something was going on, but I couldn't quite imagine what the future would be like. So when people were saying Amazon's going to be a big thing soon, everyone will be buying their shopping online. Well, how will that look when that actually happens? Soon everyone will access the internet on their phone, but what will the implications of that be? I couldn't really picture what that would mean for the world. And to be fair, I wasn't alone.
I don't think we've even seen the tip of the iceberg. I think the potential of what the internet is going to do to society, both good and bad, is unimaginable.
And I think the same is true now. It's unimaginable to us today in 2022 what the implications, both good and bad, of this technology are. But we do have our first clues in these text-to-image engines, and I want to spend today looking at how far music has come along the same path, and if not making actual predictions, at least outlining the scale of the issue. And let's start with a quick look at the technology behind this image generation to see if it can give us a few clues. So we're talking about the combination of two computer models, the foundation model and the diffusion model. The starting point was the vast amounts of data that started to become available through the growth of the internet. For the image algorithms, the first stages in around 2015 were to trawl a large collection of images from the internet, along with the text that surrounded them on the web page. And gradually the computer starts to get a sense of what objects are by building up a series of unique, specific qualities. So if it's looking at a piano, for example, it builds a series of points in a sort of multi-dimensional space. Each one of these points represents one aspect of piano-iness. A point that represents the black and white keys of the piano, another that represents different sizes of piano frame, and another representing more abstract qualities that humans wouldn't even think to name. This was very successful at figuring out individual objects in a given image, but it was taken to a whole new level with the development of the foundation model, which uses what's called self-supervised learning to understand large amounts of data. It was originally developed by Google's BERT project as a way of understanding language, and was trained to predict which word would come next based on the context. As more and more data is analysed, the system gets more and more accurate in its predictions. It has no need for any external sources for its understanding. It's just the vastness of the dataset that allows it to work. Computers were now very good at recognising the objects in an image and describing them, so researchers started to wonder if you could do that process but in reverse. Having figured out what the essence of all these objects was, could you then generate images just from a text prompt? Could I type in piano and get an image that looks like a piano? The initial attempts were pretty clunky. Here are some of its first attempts at responding to the prompt: a group of happy elephants in the dry grass. Or this one, an aeroplane flying off into the distance on a clear day. You can see the results are heading in the right direction, but the real breakthrough in this reverse engineering area came with the development of what's known as the diffusion model. Imagine taking an image of a piano and gradually adding some random noise to it, one step at a time, and just a small amount each time, until you get all the way to an image that's just random noise. And then you give the computer the task of trying to reverse engineer each of these steps. So if you have an image with a piano and just a little bit of noise in it, can you recreate from that the original image? By reverse engineering all of these little incremental steps along the way, the computers were eventually able to do the complete process and move from an image of complete noise to the specific image requested by the prompt. And the combination of these two models is the trick that has led to this explosion of text-to-image generation that we see now. So what about a similar idea but to do with music? Is that even possible? The first thing to consider is the different ways we can think about music in terms of data. The most computer-friendly music file is a MIDI file. The notes of the piece of music have already been encoded into computer code, so that seems like it might be the best place to start. But there are many problems. For starters, only a small subset of the world's music is available in MIDI format. There are collections of MIDI files out there, and some of them freely available, but they tend to have tens of thousands of pieces and not the tens of millions you'd want for a really comprehensive collection. And there are important aspects of music that can't be captured by MIDI data. For example, it can specify a keyboard, but it can't specify a particular type of keyboard or the settings used during the performance. It also can't capture the nuances of live performance, the tone of the singer's voice, or any of those subtleties of performance like pitch bends and articulations. But it's a good starting point, and the first attempts at AI were based on MIDI data. Google's Magenta project was one of the first. It was behind that Nirvana track we saw earlier. You might also remember the Google Doodle for Bach's birthday, which tried to harmonise your melody in Bach's style. That was also based on Magenta, and it learns using some of the same techniques we saw in image recognition. So take a Bach chorale, erase some of the parts, and then use deep learning to try to fill in the parts. Another MIDI-based project is Musenet, run by OpenAI, the people behind DALL. Musenet attempts to understand the musical characteristics of an artist and offers the tantalising prospect of being able to merge from one style to another. We'll start with the first 6 notes of a piece by Chopin and turn it into a Bon Jovi track. Not bad. Or we'll start with Beethoven's Fifth Symphony and continue in the style of Lady Gaga. Is that the best it could do, really?
Remember the fact that it's a freaking computer composing this.
The fact is, MIDI will only get you so far, so the alternative is to use the actual audio of recorded music, and that's a much bigger challenge because we have to tease out the individual elements from the audio. Where a MIDI file has all the individual notes nicely separated out, an audio file is just one very complex waveform, all the notes and harmonies all jumbled together. Now, desktop programs like Melodyne have shown that it is possible to extract all those individual notes from a polyphonic texture. And the good thing is this approach works for any piece of recorded music, and it keeps all of those subtleties and performances that MIDI ignores. So this approach seems more likely to be successful in the long run. Again, OpenAI seems to be leading the field. They have another program called Open Jukebox, and it allows people with a bit of programming skill to import their own data set of recordings, and it'll attempt then to create new songs in that style. Some of their examples have a slightly uncanny valley type of feel, like this quite creepy version of U2. But it's still impressive that they managed to get something that does sound a bit like Bono, and even seems to invent its own words. So some of the learning technology is in place, but so far we've only seen real-world examples that use limited data sets. The next step, which is presumably being worked on, is the equivalent of those first steps they did with image recognition. A machine that can run through all of the audio files of the world's music and gradually build up a picture of what everything is. Just as the image algorithms built up a model of what a piano looks like, it would have to do the same. It would have to build a sense of what a piano sounds like, but also what an R&B piano sounds like, what a Rachmaninoff piano sounds like, what an angry piano sounds like, and so on and so on. Even this first step would be fantastically useful, so you could just search for angry Rachmaninoff piano and get just what you wanted straight away. Maybe people are working on this and I just haven't heard about it, or possibly it's still a rather ambitious idea. A music file is a lot larger than an image file, and to understand those individual notes within a music recording requires a lot of processing, so maybe this kind of scale of things is not quite there yet when it comes to music. But having seen the speed of progress in the image world, it's hard to imagine that this isn't right round the corner. One new research paper, one new technique like that diffusion model, and suddenly the results change from an elephant in a field that looks like this to one that looks like this. Those first AI images were just about recognisable, but distant, distorted, and a bit weird. And I think that's just about where we are with music today. Before we look at what all this means for composers, let's just take a moment to consider where the technology is heading next in the visual world. The most obvious next step is video, and we're already seeing some developments in this area. So here's a TikTok I saw the other day, and an animated scene entirely generated by AI. And I'm sure it won't be very long at all before there'll be more online tools that will allow anyone to do stuff like this. There are also already tools that allow you to edit video using a prompt, remove the clouds, change the colour of the car, and so on, and combine this with the advancements in deep fake technology, and you start to see that entire scenes could be created using just text prompts. Eventually maybe even whole films, so a Mission Impossible thriller but with a female lead and a plot that involves a pink donut factory. Oh. That still seems like science fiction, but we're already so close to it. We already have, right now, today, almost all the technologies to do that in place. When it comes to music, some of the more obvious results would be that industries that use fairly formulaic music would be wiped out. You can already see the start of this with companies like Ecrit Music and Aiva, which create the kind of stock music you could use in backgrounds to a wedding video or a corporate video. After that comes film music. Imagine with a few words you can create a good replica or imitation of any style of music, or any combination of styles, and potentially even describe in detail what happens along the way. A tense rhythmic percussion solo in a Latin style. After 20 seconds, strings enter and crescendo dramatically. Film composers today already struggle with directors who've taken an existing piece of music and just want the composer to write something as close to that as possible, just without the copyright issues. So imagine if the director can sit down with a prompt and create a copyright-free track that they're happy with just using the AI. Maybe they'll ditch the composer altogether. Now for individual consumers, of course, it could be amazing. We might type into the prompt Beethoven mixed with Lady Gaga and love what we hear. And eventually we could all end up with our own weird little playlists of AI-generated pieces, all catering to whatever quirky niche we fancy. You start to see a picture of the world where most of the culture you consume is planned out for you, specifically tailored to your needs and desires, and all generated by AI. Again, great for consumers, but potentially devastating for composers and artists. So here's one of the more interesting AI music projects that I've found that exists at the moment. Reeps One is a beatboxer and rapper, so he fed examples of his own style into the computer, and it fed him a series of responses in his style.
Hear that? I'm surprised it's done that exact rhythm because that is one of my patterns.
The results were interesting enough that he found it inspiring and used it to take his art in new directions.
I'm having a conversation with this technology, which is something I think everyone is going to be forced to do very soon.
And to me, this is one of the more optimistic ways of viewing this story, as a chance to explore new kinds of creativity. Because on the whole, when new technology arrived in the past, that's exactly what happened. So for example, when photography emerged, it seemed to signal the end of painting, which was heavily focused at the time on portrait painting. But what it actually did was change the focus of painting. Painting realistic portraits was no longer a particularly needed skill, so painting had to move into other areas. One thing I have no fear of is that humanity will ever lose its need to be creative, or the need to hear art that's been created by humans. That's one of the reasons I think performance itself has nothing to fear, because if anything, the experience of hearing human performance is likely to grow ever more precious in a world where so much is done by computers and technology. There's no doubt that a great number of jobs which currently keep the roof over the heads of many composers will be disappearing in the coming years and decades. We can only hope that in their place, new kinds of artistic jobs, whether it's prompt engineering or something we can't yet imagine, will emerge to take their place. Whatever you think of its pros and cons, as Reeps One suggests, AI music is coming and coming fast. And if, like me, you've tended to sneer at the pretty mediocre musical results it's produced to date, don't be fooled, it's very much on its way. So I hope you found that interesting. I found it a lot harder to come up with a coherent argument than I initially thought, but hopefully it gave you something to think about, because it certainly did that to me. If you'd like to support me making more videos like this, do consider joining my Patreon, and thanks to everyone who supports me there already. Thanks very much for watching, and I'll see you next time.